All right, today's objective is that you will find places where instantaneous slope matches average slope using the mean value theorem. Um, so just as a reminder, the mean value theorem says that if you have a continuous differentiable function between two endpoints, and you take the average slope between them, which is represented by this line. Sorry, it's not great. So this is the average slope, also called the secant line. Um, if the function is closed and continuous and differentiable, there must be some point that has the exact same slope, which is the instantaneous slope, between these two endpoints. So our goal today is going to be to find that point for which the instantaneous slope matches the average slope. In the first example here, we have the function x squared plus 3, and the interval is 0 to 2. So the instantaneous slope is easy. Instantaneous slope means derivative. And the derivative of this particular function, x squared plus 3, is, of course, 2x. The average slope is found by using the slope formula. So I'm going to do this off to the side as a little bit of scratch work. F of 0 and f of 2, because they gave me two x values, but I don't know the y values. So f of 0 in this case is 0 squared plus 3, so that's 3. And f of 2 in this case is 2 squared plus 3, which is 7. So our endpoints are 0, 3 and 2, 7. Probably could have done this completely in your head. So our average slope would be y2 minus y1 over x2 minus x1. So that's 7 minus 3 over 2 minus 0. And what the mean value theorem says is that because our function is continuous and differentiable on a closed interval, these two values, the instantaneous slope and the average slope, must be equal, and therefore we can find a value of x in between 0 and 2. So I'm going to start solving this. 2x equals 7 minus 3 is 4, divided by 2 is 2. And when I solve this equation for x, I get that x equals 1. 1 is indeed in that interval as the mean value theorem promised, so that's it. That's what we were looking for, and we're done. Really quickly, just to show what we found here, this point was 0, 3, and then this point was 2, 7, and so we found a point in between at x equals 1 that has the same instantaneous slope as the average slope between those 2 points. So I'm not going to draw the picture for the next one, but it is similar. Second example, we have a function that is continuous and differentiable. This is an exponential function, so we can take a derivative, nothing fancy like absolute value. And we have a closed interval, so this is going to apply with the mean value theorem. Our instantaneous slope, we're going to take the derivative of this. So the derivative of e to the 2x is 2e to the 2x. And the derivative of 1 is just 0, so we use chain rule there. And our average slope, well, we need to find our y values. F of 1 and f of 5. So this is quite a non-in-your-head problem. So over off to the side on my calculator, I'm typing in e to the 2 times 1 plus 1, and I'm getting 8.389. And f of 5, when I plug that in, I'm getting, and this one's going to be big, 22,027.466. So sorry about the lack of space, but all we're doing here is finding the y values that go with these x values. So our average slope is slope formula, so that's going to be 22,027.466 minus 8.389 divided by the x values of 5 minus 1. So this is rise over run. The mean value theorem says that these must be equal, the instantaneous slope and the average slope, and now we're just going to solve. So starting over on the left, starting on the right, 22,027.466 minus 8.389 divided by 5 minus 1 comes out to 5,504.769. And on the right side, I haven't done anything yet. I'm sorry, on the left side, screwing that up a lot today. So that's still 2e to the 2x. At this point, everything's going to be solving. So we're going to divide both sides by 2 to cancel out that one. And I'm showing all the work here, but you can probably see where this is going. Which gives us e to the 2x is equal to 2,752.385. To get rid of the base e, we're going to use natural log on both sides. So natural log of that number. I'm almost out of space here. Sorry about this. So this is going to give us 2x is equal to the natural log of that answer is 7.92. Actually 920, but I'm out of space. And then, of course, our last step is to divide by 2. And when we do that, we get that x is equal to 3.960. We can double check that we did it right. 3.96 is indeed in that interval. And so we're done.